Okay, let's start the class. Good evening, everyone. Good evening. Okay, so today I'm going to talk about the applied SCM. Okay, and then actually we can go to the up to you either business or like you want to apply it to the human factors and ergonomics or any other topics. Okay, but for me later on, let me try to show okay from the introductory and then up to the advanced level, and hopefully we can run one STM. I can show to everyone how to run it, and then from the zero up to the final final model, okay, for the SCM. And I believe perhaps Maela already got used to it, and I think Mom Janice and Mom Mom Rhea already know about this one. A glimpse that perhaps that we can dig into.
Yeah, glimpse only.
Yeah, a little bit deeper. But I know, for example, Anthony Bello, perhaps this is new for you. So okay, this is a good chance for you to learn what is SCM. Okay. So again, Mom, there are many things that you need to pass first before you go to the SCM. But later on, it's actually not that complicated. Okay. So it's actually when there is a correlation, Ma'am Boris, applied so many things with the correlation. Of course, we can do with the multiple linear regressions. And then from here, some studies, it can go to the this one, to the structural equation modeling. But if not, for example, using this one, it does not work. It's okay. We can just utilize the multiple linear regression. Okay. This one is actually just a basic concept. Okay. That in SCM, there we also do the kind of like factor analysis, but we actually make it a confirmatory. We confirm the factor analysis, okay? And then I can show to some model. Okay. Okay, of course, everybody knows correlation analysis, right? There are so many, everybody knows already about the correlation analysis, and SCM is actually starts with the correlation analysis. Okay, for example, we have certain variables, okay, in here, and we would like to see the connection. Of course, you can see either it's positively correlated or negatively correlated, and then of course, the higher it is, the stronger the correlation, and regardless the how is it that regardless whether it is positive or negative. For example, this one, this is actually the strongest correlation in this one because this is a 464. Okay, and then this is the basic concept. And then I would like to emphasize that you would like to show the correlation analysis, please just do one triangle. Okay, this is a journal format because later on, if we submit a paper that utilize the correlation analysis, it's better for us to use this one because later on the editor will ask us to how is it that to eliminate the other one, okay, to make it tidy. Either you like this triangle in here or triangle in here, but for me I like the triangle in here. Okay, so that's the thing that we need to do, and then we need to show usually the mean, standard deviations, and the range, okay, for each of the indicator. This is actually the standard. If you would like to make it like together, the format would be like this one. But usually for structural equation modeling type of of study, they do not show this correlation analysis. They don't show this this triangle. Usually we don't show this kind of triangle because imagine if you have 59 questions and then here 59 questions, then what will you do? That's why usually people do not show this kind of correlations. Okay, people just show the mean, standard deviations, and then later on the factor loading and so on. Okay, now we can go to the multiple linear regression. Of course, if there is a correlation, we can go further into the multiple linear regressions. But anyway, multiple linear regression is totally different with the logistic regression. So Maela, do you know what's the difference? Now I'm going to test your knowledge regarding the multivariate. Do you know what's the difference between multiple linear regression and logistic regression?
Yes. For the logistic, if I remember it correctly, for the logistic, there's only 0 or 1.
Yes. Yes, correct.
Okay.
Yes,
I
that's
was
correct.
a bit nervous.
Yes. Yeah, okay. I just want to ask you, you know what, like because there are some studies, of course. For example, if your y is just yes or no or die or not or positive or negative and so on, yes, you can apply multiple linear regression with 1 and 0, but later on the model will be very bad. Usually the model fit is bad. So in here, if this one is not yes and no, and it is actually a metric or measurable scale, okay, we can utilize the multiple linear regression. Okay, don't worry, we will talk about the survival analysis during the accident analysis. At that time I will talk about the binary logistic regression, because logistic regression is very common in the public health. It's the public health style, for example, okay, yes and no. But in here, for the scale in here, it's only for the not yes and okay. And then P0 is actually the intercept. Of course, everybody knows this one. And then this is the coefficient and so on. The higher the beta, of course, the stronger it is the effect to the Y. And then based on this one, actually the multiple linear regression, okay, we have to, I would say, we have to disadvantage, okay, of the multiple linear regression. Okay, the first disadvantage, it's actually this one. Okay, the first disadvantage is actually we can only predict one y in one time. We cannot predict two y in at the same time. So if you would like to run a certain equation like this one, we have to do it split, in Minitab or in SPSS. Later on, we have to do it like twice. Okay, that's the first the disadvantage of the multiple linear regression. Then the second is actually we cannot see the causal relationship between the independent variables. For instance, perhaps x, y, and x2, we can we can see also the connection between x, y, and x2. Okay, so we have two limitations when we conduct a study using multiple linear regressions. That's why that's why this is the first thing that we need to understand before we go to the structural equation modeling. Okay, up to here, Ma'am Bores, is it clear? Ma'am Kumasing, clear? Very clear.
Yes, sir.
Yes, very clear, very clear.
Yeah, it's very simple for this one. Yeah. Okay. For example, in ergo later on, we can see, for example, this is the grip strength, this is the this is the grip strength, this is the hand size, or male. Of course, male will have the higher hand size, and then male, of course, male is stronger than female. The grip strength, not just because the male is actually has higher anthropometric dimensions, but because the gender itself. For example, male and female who has the same anthropometric, still male is actually still stronger than female. So that's why we cannot see the causal relationship between the independent variables if we only utilize this one. That's why multiple linear regression, usually the title is predictive. Yeah, predictive model, or like a mathematical model, something like that one, usually for multiple linear regression. Okay, but another term that a little bit different with the multiple linear regression later on, perhaps next 2 weeks I will talk about the binary logistic regression, when the y is actually just yes and no, or that or not, or like for example, the senior high school, let's say, like there's so many variables in here, whether they will like to stay in Mapua for the college or not, is actually we can predict using the binary logistic regression. Because later on, for the binary, because only yes and no, it's not straight like this one, it's kind of like a sigmoid function. So it's going to be like a curve. Yes, Ma'am Janice, what happened?
Dr. Okay, just question. What is the minimum R-square value for a multiple regression model to be accepted for publication?
Usually, I don't know. For journal publications, my advisor for my master degree, Dr. Chi, she published one. It's just around 50%. It's still okay, ma'am.
But
actually
below 20%.
But that one is very 20 something is very low. Yeah, it's not even straight. The line.
Yeah.
Oh, let's
with a very low R-square model. So this cannot be.
I think, yeah, I don't know, for 20%. I don't know, but 20%. I don't know.
Okay.
Ma'am Boris, do you have any idea? Like, but for that one.
But thumb is
sir,
50, at least 50. Rule of thumb.
40, 50. I think around that one. I think
Okay,
I don't
okay.
have. I don't
Okay.
set. I don't set actually exactly the number
Okay.
for that one, mom. But
but not below 20.
no below 20, of course. The line will be like.
I think,
Okay.
sir, if you ask then Mike, and we're talking about stocks,
Okay.
I think he has a lower R squared. I think he explained it last time that depending on the situation, especially if we're
Okay.
talking
Oh,
about
yeah.
stocks, you can expect a lower
Yeah.
R
Actually, I
squared.
also read some articles that if your data is more on like psychological something,
Yeah,
Yes.
it has
behavioral.
lower,
Yeah,
yeah,
behavioral.
behavior,
Yeah.
lower,
Yeah.
lower R
Yes.
squared.
Yes.
Okay.
Yes.
Okay.
Okay. Yeah. Dean Mike is
Let's
Dean Mike
start
is more
with
expert.
20%.
Yeah, is more expert than me for that one. So in time series, of course, it's his expertise. Okay.
Probably, sir, because of the stock portfolio also.
Yes.
His
Portfolio
topic
is
is
always
more
time
of
series.
the
So,
stocks.
yeah.
Yes.
Okay, so we go back to the basic assumption, okay, for multiple linear regression. Okay, do not forget for usually when we report about multiple linear regression, we report the autocorrelation and then multicollinearity. But this one, normality, homocadasticity, and dependency, usually we do not, in general, people usually report these two. But if you would like to show these five, that is also okay, and so on. So the Durbin-Watson, we have the value 1.75 until 2.25. So it means that there is no autocorrelation. If there is higher, there's lower, then there is autocorrelation either positive or negative. And of course, for the VIF is for multicollinearity. So these two is actually quite important for if you would like to, show equation using multiple linear regression. But anyway, Ma'am Gumasing, I published in IEM with look at this one, and I'm quite confident in
See,
front of.
I also have that data, so I can publish it in a conference.
This is IEM, so I got something IEM, so why not? So that's why, I mean, when I was in Macau, everybody's like, wow, and then so on. But when they see the result, they kind of like holding not to laugh. And I'm just like, yeah, I know. At least, but this is actually how we say that, mom. That time, we like vacation, right? So like before the COVID, we would like to.
Yeah, that's 2019. Yes, 2019.
Yes. It's actually before. This is actually before the. I would say that before the pandemic, and IEM is actually quite big. It's actually very big.
Yes.
We can see so many top professors there in IEM. So yeah. Okay. And then we can of course we show the collinearity diagnostics and also the Doppler-Watson. Okay, just show this one. Okay. I believe this is actually quite easy for everyone. Now I can go with this one because this is a little bit tricky. Okay. Ma'am Herman during the defense. Now I realize that during the defense of I forget who was that. She actually mistaken the term between factor analysis and cluster analysis. These two are different. Okay, factor analysis and cluster analysis. Maela, do you know what's the difference? The very basic, the standard difference, the cluster and the factor. Maela, if you cannot answer, then I will call the register office to change your multivariate score.
For
basic concept,
factor
right? Yes.
analysis, we have to group the variables.
Yes,
So we have to know which variable would go to, let's say, group 1, group 2, or group 3.
And what about
For the other
cluster?
analysis, we have to separate them.
Oh yeah, I forget. You're Dr. Ferras, one of the Dr. Ferras' favorite. That's why you're expert. You're more expert than we in cluster analysis. Okay, of course. Anyway, okay, the difference between factor analysis and cluster analysis, these two are totally different. Okay, factor analysis, of course, we group the factors. So later on, for instance, we have a group like let's say this one, NF, EMT, and parallax. If we do the factor analysis, if these variables, go to one dimension, we reduce it into one, we merge it into one, then that is what I call the factor analysis. So that one is not what we call cluster analysis. That is factor analysis. We merge the factor. But cluster, cluster is actually clustering the individual, clustering the respondents, or clustering the, I would say that in the Excel is quite different, Cluster analysis is clustering the y-axis. Factor analysis is factoring, grouping the x-axis. So that is the easiest way. So the x-axis, we have so many variables, diba? So if you would like to reduce that one, then it will be factor analysis. But for the y-axis, if you would like to group the y-axis or the respondents itself, that is what we call cluster analysis. Is it clear, Ma'am Gumasing and Ma'am Bores?
Yes. So it's like if you have
Yes,
several
sir.
indicators and you want to know what would be the major indicator, you can perform factor analysis.
We merge based on the similarity.
Yes.
Based on their
Okay,
similarity.
to know.
Yes.
Okay.
Yes. So we try to
Similarity
merge it.
in terms of the scores of the respondents.
In terms of the data, in terms of the
Yeah, data.
in terms of the data, essentially in terms of the Euclidean distance. Okay, but I'm not going to talk too much to mathematics.
Okay, so you need to have data first before you can group the factors.
Of course, yeah, that one. Okay, so that's why after collecting the data, we actually would like to see what kind of, can we merge this one without, we don't know the pattern actually, so that's why we would like to see, so it will be like this one. Okay, the factor will go to this one, but cluster is actually a little bit different. So cluster is actually clustering the respondents or the y-axis, the one in the y-axis. So that is the biggest difference.
Dr. Yugi, another question. What if you already have a questionnaire with indicators per
a certain, right? For a certain factor,
yeah.
right? Yes, that's
do we
what.
need to perform
yes.
again another factor analysis?
No. So that's
confirm? No need.
Yeah. You actually asked the basic questions, So if you decide which indicator under which factor, that is what we call confirm. We confirm it.
Okay,
that's why we call it yes, that's why we call it confirmatory factor analysis. That's why we call it like that's why we call it, we confirm it. But this one we call it exploratory.
Okay. So that's difference. Okay, exploratory and confirm. Okay.
Yes, so that's the biggest difference between exploratory and confirmatory. So exploratory, we just explore.
Okay.
Let's see how it goes. But if we decided before we collect the data, that's what we call confirm.
Yes. Okay.
Yeah.
Good.
Okay, Mambores, clear? I think it's okay. So far, okay? No?
Clear, sir.
Yeah.
Because of Jenny's question.
Okay.
Thank you,
Okay.
sir.
So later on, this is actually the another one. We call it this one. Principal component analysis is the same, like factor analysis or exploratory factor analysis. The same. It's like another term, another term. But this one we call it. This is actually exploratory factor analysis, and this is actually what I call the confirmatory factor analysis. So these two are a little bit different. So exploratory later on. You like this one, and then this is actually a confirm. Let me go to the next one. Even much, I would say that perhaps clear. Okay, this is the PCA. Later on, ma'am, these four it will merge into one. That's why this one in the exploratory we call it dimension reduction. We reduce the dimension or we reduce the factor. So that's why later on this one. Let's say this one is hand size. Head size and so on. Perhaps it goes to one dimension. We call it anthropometry, but it's actually we give the name after we run it. Okay, but this one is different. We said it before. Oh, later on the head, blah blah blah. It will go to the anthropometry. So it's actually we decided before. This one is actually we decided after. Okay, so later on in this one, ma'am, we do not reduce. We don't reduce it into into one. We just keep the original like this one, but later for this one we reduce it. Actually it goes to one. Let me make it clearer. The next one I think will be much clearer for everyone. Okay, this one. Let's say this one is of reservation, check-in efficiency, and then and so on. And then this one spa, lobby, security, and then the swimming pool and so on. So later on, ma'am, based on all of this, we can reduce all of these variables, all of these factors into actually the software make it into 7. Actually they by nature they decided into 7. And then from this 7, how we know which one belongs to which new group? Look at this one. So this one, the highest number is actually in the column number 1. So later on, everything in here belongs to the 1. You know, we can merge all of this into 1. But the difficulty for factor analysis is giving the new name. That is difficult because we just explore which one close to which one. You know, if we see like this one, then for example, this one, refund, discount, room size. This is difficult, right? How we merge this one? Price is actually belongs to this one too, actually, because this is the highest number is actually in this table. The same with this one, spa, lobby, security, you know, it belongs to this one. How we name this one? That's difficult. So that is the challenge in exploratory factor analysis. But exploratory factor analysis is very common in the cognitive ergonomics, especially for what? You know, Maela, your favorite. One of your favorites, I think.
Yes, for cognitive.
For what? You know, what topic? Do you know?
For this one.
Kansei.
PCA.
For Kansei.
Kansei.
Yeah. So later on, I think hopefully next week, I will talk about Kansei in the cognitive ergonomics. It's actually very common to utilize the factor analysis, the Kansei. And you know the big 5 personality traits, right, Maela?
Yes.
It's the same like this one. The story of that one, you know, I just read the book about history, about the psychology, and I realized how they decide the big 5 personality traits in the HR is actually from the factor analysis. Really, from
I didn't
tremendous,
know that one.
really, it's actually from a tremendous how say that it's actually from exploratory factor analysis. So that's why, but that one is to psychology. Okay, but anyway, for us, exploratory factor analysis, we will use this one a lot for the Kansei, usually. Okay. Now this is actually the structural equation modeling or confirmatory. So actually, we decide that one first before the collecting the data, before conducting the research. That's why SEM, you know, some researchers agree to say that SEM is actually just a combination of factor analysis combined with the regression. So multiple linear regression and the factor analysis, you know, that's why I make it like this one first: correlation, multiple linear regression, factor analysis, and SEM. Because if I jump directly to this one, perhaps some people will lose a little bit story in at the beginning in this one. Okay, so let me go to the next one. This is actually a multiple linear regression model, right? This is like exactly like multiple linear regression if we make it like this one. But what is the difference with the multiple linear regression? Maela, do you see something? What's the difference? If we make it like this one, which one?
We only have one dependent variable.
But what is the difference between this one and multiple linear regression, standard one? This one. Can you see that this one?
Yeah,
like,
you can
we also
only
conduct a correlation, right? Yes, we also conduct a correlation. Like, yeah, this is simple, the same. But now, remember, I explained before that we cannot explain the you know, the relationship between this one simultaneously if we only utilize the standard multiple linear regression. For example, like what I've mentioned before, gender with the hand size. Yes, there is an effect of gender to hand size, but if we just predict the grip strength later on, we still cannot see in here. But if we see this one, we also can see, you know, in here. But of course, for example, oh sir, what about this one? Is this the same? Yeah, of course, this is actually the beta coefficient, right? The higher it is, the stronger the effect it is, right? The same with this one too. Now, I go to the second limitation of the multiple linear regression. If I add one more y, look at this one, adding more difficulty. So this is actually we can run simultaneously in one, how we say that, in one model. And moreover, we also can see how big the effect of x1 to the y or x1 to the y2 simultaneously. Which one is bigger? X1 to y1 or x1 to y2? Yeah, we can see that simultaneously using one model like this one. X2 to x2 has a bigger effect to y1 or y2, or y1 is actually more affected by x1 or x2. We can do it simultaneously using the path analysis. This is what we call path analysis, or yeah, just the SEM itself. Okay, and then we also can see the correlations in here, but usually people do not really care about this one. People usually care more about this one. Just imagine if you do the ANOVA, what will happen? If you do the ANOVA, what will happen? Then it will be, it will be like one by one. Like you have to run it splitly, more complicated if we do it by ANOVA, or we do it like well, I would say that regression, because regression is only one line, diba? If this one, how many? 1, 2, 3, 4. So there are 4. So that's why it's more difficult. Okay, so far, is it clear? Ma'am Bores, clear?
Yes.
Yeah.
Yes, sir. Yes, sir.
Yeah, it's very clear, right? Okay. Now I go
Yes,
to the Now I go to the next one, ma'am. But for example, ma'am, if you would like to add extra, how we say that, publications, this one, number of scopus and so on, we can do it like one with multiple linear regression, one with how is it?
Correlation.
Yeah, go with the SEM.
Different. It's same data.
We will do that, sir.
Actually, but put into 2 different conferences, so at least people
Yes,
will,
yes.
okay.
Different conference.
So that's why until I also
I
did
should
like
learn
that.
that, sir.
I also did I did that during my early, after graduated from PhD. I did that, and basically one day that the same with Dean Young. He also did the same thing. I mean, we actually we like one data, and then we try to like this one, and I presented to one conference. I mean, people will say like, wow, it looks amazing. You did so many publications with that one. But if we really take a look, like, oh, it's actually nothing. That one. Even like the publishing R square like only 20%, and so on. Anyway, that's another way. For example, like, but now I'm busy enough with, like, I have so many papers to do, so that's why like I don't do that anymore. Okay, now is actually we can see about the full mediation and partial mediation. For instance, that if we correlate directly, for example, X and Y is actually not related. Even using the Pearson correlation, for example, let's say, oh, there is no connection between X and Y, but how is it that? But if we split it like this one, it will be like actually there is a connection between X and Y because of the mediation of the M. I have a unique example for this one. It's actually like someone who has HIV. So, for example, this person, with this person go to a hotel, okay, let's say. And then this person is actually go to another hotel, okay. But for example, the Y is actually got affected HIV actually from the X to the mediation of the M. So that's another story, okay, how I create when I look at this one. But B is actually different. B is like COVID-19, okay, or like flu and so on. B is actually like this one. B influenced M, B influenced Y too. Like when you meet up with these 2 persons, and X is actually someone who has a positive COVID-19, then it can actually like transfer to M and transfer to Y. And for example, later on, Y, if they meet up with this one, it will be like a big combo. It's like the chance for this one getting a positive is even actually higher if you can see, there is a direct and indirect effect. So later on, the total effect in here will usually is actually high. But now the problem is, if we do multiple linear regression, it's like, can we do multiple linear regression? Of course, we can do it with multiple linear regression. It's like X to M, this is one regression. And when we can do another regression, we also can do it. But the journal mentioned this one. Okay, this one is like transferring water. For example, we transfer the water of this spray to another bottle. But usually, if you try to transfer from X to M, when you pour the water, there is a small sprinkle that's missing. Like small amount of water is actually missing. The same thing with this one. If we would like, we do this one and then continue to this one, there is a small amount of data, or like it's not a small amount of data. I don't know. It's so mathematics. I'm not mathematicians. They mentioned the one that I got. The logic is like that. Like it's not that smooth, I would say, if we make it a double regression like that one. So, but if we make it like together connected like this one, it's like connecting how is it that it's like a tunnel, you know. So that's why there is no liquid water in here if you make it together like this one. But if you like to it this one and cut and then do another one and cut, you know, the result usually is not that small. Okay, this one, is it clear so far? Okay, Ma'am Gores, Ma'am Jenny?
Yes, sir.
Good.
Yeah, okay. So now I go to the next one. Okay, this one is actually let me just finish this one. Okay, so okay, wait. That one is actually okay. Wait, this one, this is actually part fine. Okay, okay. Now, okay, this is actually the basic of the how is that? This is actually the basic picture or the basic thing about the structural equation modeling. Okay, the one that has a circle or oval is actually, we call it latent variable, or we call it unobserved variable. There is no data in here, but we make it into like just like how is it? For example, anthropometric, you know, for example, it's actually being measured by, you know, another a certain, you know, measures. This one is actually the indicators. I know everyone already knows about this one. This is indicators, and then it's actually another term is actually observed variable, so we can get the data directly. Okay. So and then the connection between the latent and the indicator, we call it effector loading or loading factor or lambda. You know, the symbol is actually the lambda. And usually the minimum cutoff is 0.5. Usually the minimum, very minimum cutoff is 0.5, but higher than 0.7 is actually the one that we want to get. But what happened if it is higher than 1.0? Maela, now this is the PhD level. What happened if it is higher than 1.0? I haven't explained about that one, of course. You don't know that. I think you don't know the answer.
I'll try to guess.
Okay.
Maybe there is an overfitting.
Overfitting. Yes, actually some parts of can be, yeah, because you got the term overfitting from data mining. Okay, yes, can be. But that one, you know, when the factor loading is higher than 1.0, that is what I call Hayward effect. This is the term, Hayward effect. That one. That's why when I ask you, is there Hayward effect? Do you know Hayward effect? Hayward effect is actually a condition that the factor loading is it's actually it's actually overfit, or it's actually higher than 1.0. Then what will happen with that one if it is higher? For example, 1.03. What will happen? Later on, if the factor loading is higher than 1.0, we just make it 1.0. Then what happened with the rest of that one? If you make from 1.03 lower a little bit to 1.00, then what will happen with the rest? Can you guess, Maela? What will happen with the rest? Is it higher or lower? If there is an earthquake in here, oh, why lower? Should be higher, you know. The extra energy goes to another one. Actually, the concept is like that. So yeah, the extra energy later on, for example, 0.75, perhaps later on just go a little bit high, 0.76 or 0.77, perhaps just a little bit. Just a little.
All right, that's why every time we remove an indicator, our values also increase.
Yes, it's actually because of you know.
Okay.
Yeah. So later on, when if it's higher than 1.0, that is the what we call Hayward effect. So if someone publish something and there is a Hayward effect, you can laugh like, hey, you forget to remove the Hayward effect, you know, like that one, you know. Sometimes, you know, in international conference, sometimes I ask question, you know. Actually, I know, like the person just, you know, forgot to run it, you know, and some researchers just like you know, acknowledge that one. Oh yeah, I forget. There is a Hayward effect. Okay. So and then this is the factor loading, okay, and then this one, this is like the beta coefficient, okay, just like the beta coefficient in the multiple linear regression. And the minimum cutoff of this one, there is no minimum cutoff as long as the p-value is significant, is significant. But usually, based on my experience, 0.15, more than 0.15 is already significant usually, you know, in here.
but you cannot just have a sense of just,
for example, 0.20 is significant, you can just make it, oh yeah, 0.30, let's just set it, oh, that's significant, you have to double check the p-value. Wait for a while. Okay, and then later on, of course, the higher it is, the higher the effect. Okay, of course, just like the multiple linear regression. Okay, and this one, the Latin that is actually not influenced by another Latin, we call it exogenous. This is actually the endogenous. This is actually the endogenous. So far, so good. I think this is quite okay for everyone. It's just a old review for the terminology, I would say. Ma'am Gumasing, clear?
Yes, clear.
Yeah, Ma'am Boris, clear?
Sir, sorry. I didn't hear the difference between endogenous and exogenous.
Okay, because this is like independent and dependent, something like that. As simple as that one, Ma'am. Independent and dependent. Yeah, so endogenous is always the dependent. Yeah, the one that's actually affected by another one. As simple as that. As simple as that. Yeah, that's the endogenous. But later on, Ma'am, usually the BS students sometimes like, so Yogi, my program does not work and so on, and then anyway, I say like, hey, you forget to put error in your endogenous, and then they don't get what I'm talking about. I'm like, sir, what is endogenous? I'm like, okay, then you need to learn the basics. Okay.
Okay, sir.
Questions, ma'am?
All right, thank you, sir.
No other questions?
Nothing, sir. No.
Okay.
Thank you, sir.
Okay. Now, this one is actually a little bit. I would like actually I choose this one. Actually, I just want to show a little bit, another case in the structural equation model. Okay, this is actually this is there are two Latin in here, and then this is actually the effector loadings. This is the beta coefficient. Okay, now what about this one, Ma'am Gumasing? Just guess. This is effector loading or the beta coefficient, and why is that? What's the reason?
Beta.
Yes, this is the beta coefficient because,
yes, because
this one, yeah,
directly affecting the what is PEDM?
Yes.
What is PEDM?
Yeah. This one.
What is PEDM?
This one, protective action decision.
Okay, protective. Okay.
Yeah. So this one, female is more protective. Wow.
Yes, we're more protective.
Yeah. I think so. Okay then. And then this is exposure. The exposure will affect the protective action decision model. But this is very simple, right? Maela, can you imagine, this kind of study can be published in look at this one. This is just a Hurricane Katrina, Hurricane Rita, and so on. Whether this one has a influence on this one, and look at the factor loading, it's very low, right? But this one only like 1, 2, 3. This is actually good. The rest is actually not good. This one is like 1, 2, 3. Yeah, these 3 are good, and the rest actually not good.
So Dr. Yogi, in our final model, we will disregard the indicators with a very low factor loading.
Yes, usually, usually we need to remove it. Yeah.
Okay.
But don't worry.
Run again.
Yes.
We will run again the model.
Yes. Usually
Okay.
it's kind of like that. But don't worry. Progress in disaster science. Oops, I'm recording this project, but it's so journal. So
Okay.
I think I kind of know, for this one. Okay. So this one, of course, everybody already knows this is the construct, okay, or another term we can call it construct and so on. And this is actually the Latin. I would say that this is actually the indicators. But Maela, I forget. I got attacked by many. It's not attack. I would say that people criticize my paper because I forgot to run the reliability. You know what, Maela? But
the composite reliability.
yeah, I forgot to. So I mean, but so far in my academic career, this is my best paper so far. Not my the most favorite, not my number one that I like the most, but I realized that after submitting that one, after publishing that one, then I realized that actually a professor from a famous professor of public health, emailed me, just like mentioned like, oh, Dr. Prasetyo, why don't you run the composite reliability? I know your factor loading is high. But it is a standard that you need to put the result of the reliability test in your paper. So I was like, oh yeah, I forgot that one. But you know what? If I would like to, I cannot change anything, right, regarding this publication. But if I would like to add something, there is a term called corrigendum. Corrigendum is actually, it's like the author would like to apologize, or like the author would like to edit something, but later on in Science Direct there will be two, but the other name is actually corrigendum. It's actually you would like to correct something, or you would like to add something in something that you already published. So is it possible? Yes, it is possible. Because I did not take the data and so on. It's just like the thing that I would like to add in that publications. That's what I call corrigendum. Okay, so later on in Scopus, there will be two the same title, but the other one is actually corrigendum. So that's actually a correction that because we cannot change anything once you click the final one. So that's why before publishing this one, usually I will force everyone, hey, are you sure? Double check. Are you sure? Double check. Because once there is another one submit, once you the final submission, sorry, it's not the final submission, the final proof before the publication. So usually I'll become so strict and I will look at, okay, because if you make a mistake, then until the rest of your life you cannot change it. This one is just simple, just like the question made by Mambores. For example, this one, then later on we can see there are two exogenous and then two endogenous. So usually the student forget to add this one. Usually student forget to add this one. That's why their model does not work. For example, when I say like, hey, you forget to add error in your exogenous. Remember the concept of the regression? In multiple linear regression, there is error. Always there is plus E, right, at the end. So what is that error? Yeah, the same thing with this error. Exactly the same thing like in a multiple linear regression. So that's why when I say like, hey, you forget to add error in your endogenous. Usually some students, they don't get what I'm talking. They don't get the sense what is it about. So it's actually they forgot to add this error in the endogenous. So exogenous is fine. This is endogenous. Okay. What about this one? This is actually just the covariance. Can we not add this one? Yes, it's okay. Without this one, it's also okay. We don't put the covariance, but this one they put it the covariance like this one to see whether family has a kind of like correlation with the cognitive. Yeah, they add it like that one. Okay, up to here. So far, so good.
So far, so good. Question.
Yes.
So only the endogenous variable has error, right?
Yes.
No error for exogenous.
Yes.
And how can we know the error? Where will we get the value for the error?
Oh, there is no value, ma'am. Later on.
And how do you know the error?
Later on they have the value, diba?
Okay. By running the model.
Yeah, in the multiple regression, the same thing, right? At the end, like actually the equation in multiple linear regression always there's always error, diba? This one yes, error, diba?
Yes.
The same concept.
Okay.
Yeah. Exactly the same concept. Okay. Look at this one. There is error, right? This one, because this is endogenous, so this is actually the error. The error that we need to add it. Okay. Any other questions, Mambore?
Regression. Just ask question later. Sure, thank you.
What question? What question, Mambores?
Sorry, none yet, sir.
Oh, not yet. Okay.
I'm still grasping the concept.
Oh, okay. Okay. Still processing the concept. Okay.
Yes,
okay.
Sir.
Okay, it's fine. Okay, this is actually the thing that in Ergo, especially for Ma'am Gumasi, when we have objective and subjective measure at the same time, that's the beauty of the Ergo. So my PhD advisor, Dr. Jolene, and another one, my PhD co-advisor, Dr. Bernard, two of them, they always tried to force me like, hey, you know what, Yogi, you need to think about the objective and subjective measure at the same time. If you have objective and subjective measure at the same time, usually that's the beauty that you can do in ergonomics. And then the difference between us and OR, researchers in OR or in production or in IT, because in my university there are four. We actually split into four. For example, me and Dr. Farah, I never been in the same class. I thought, never, because we are totally two different, two different worlds of IE. But the thing that I would like to highlight is actually this one, the subjective measure that we would like to add, okay, for each of the data collection. So this is don't worry. I actually, when I go back to the Philippines, hopefully next year, or I think it will be fine next year. I will buy eye tracker. So we no, not the 1 million pesos one. It's actually the cheaper version. It's around, I don't know, I forget. It's around wait, let me count in pesos. Actually, I would like to, I can buy it now, but if I buy it now, it will be useless because what for? I cannot recruit participants, and I'm afraid to to ask, to call participants to come to my house. If I have to disinfect all how is it that my house all the time, if so many people from outside come to my house. No, it's not that expensive. It's just around 200,000 pesos, the one that I'm going to buy. So later on, don't worry. We can, for example, like next year, if I have eye tracker, we can run the eye tracker. Yes, Ma'am Gumasing. What happened?
Just want to confirm, in SEM, can we have indicators with different rubric scale? Because you mentioned in that paper,
Yes.
you have subjective and objective. So it doesn't really have to have the same rubric scale, like 1 to 4 or 1 to 5. It can be different.
But yes, but there is one thing that we need to be careful.
Okay.
For example, this one, Mom, in your model, I think I found a problem. This one is like 1 to 3. This is 1 to 4, 1 to 5, 1 to, for example, this is like, let's say 1 to 5 Likert scale. This is 1 to 4 Likert scale. This is 1 to 3 Likert scale. So later on, it's not balanced, well balanced in here, in this Latin. So I think that's the, for example, you already define it nicely, under this Latin, but when you split that one, the data, it should be equal. For example, Mom, I have actually this is very, very good question. You raise very good questions. Let me open my publication that got rejected. My first publication related to the Marinduque is actually got rejected. But I knew why it got rejected, because I realized that I made a mistake. And the mistake is actually quite, I was like, how come such 53,000 data? I got 53,000 data, the data from CBMS of Marinduque, and they actually store the data nicely. And I was very surprised that my paper got rejected. I was like, oh, what happened now? But when I read the comment, I'm kind of like, oh yeah, it really makes sense. I was at the comments of the reviewers, but I submitted again. So I kind of like rebuttal of the reviewers' comments, and the reviewer actually accepted my paper. Okay, let's see. Okay, wait for a while. This one. Previously, okay, for this one, previously, this one. Look at this one, Mom. For example, typhoon experience. See, I make it everything into the same scale, 1 to 5, 1 to 5, and 1 to 5. So, and when they asked to me, how did you decide 1 to 5? Just like Maela, just like in the data mining, we have to do the data pre-processing, remember, Doc Farah always do like, hey, you know what? You have to do data pre-processing all the time. Like she always forced to do that. That time I forgot. So later on, for example, flood experience, perhaps it's just one. For example, perhaps they are the maximum number of flood experience is 10. So later on, this is 10. But now I connect with another thing that is actually not. For example, this one, vehicles. If I do not make this one, it will be like thousand of it's not equal, right? The balance of the scale. Maela, you got what I'm talking about? This one. the balance of scale, or Ma'am Gumasing, you got the sense for this one, right?
Yes,
Yeah, right?
yes.
It's not equal, so that's why that's why when they say like the way you divide the data is not equal. For example, yes, if you would like to make everything into like
1 to 5, yes.
for example, into 1 to 5, then I would like to say this one. So the minimum number and the maximum number are split into 5. So everything in here, ma'am, later on, the data pre-processing, it's actually 1 to 5. So it got rejected only because at the beginning, okay? At the beginning, it got rejected only because I forgot to run this one. For example, this is percentage, and then this is just the scale is not. It does not make sense for when they say like that one. I'm like, yeah, it does not make sense. And then another one is actually, there is another one because we created. Actually, I joined this one late. Actually, they already conducted the project for, I don't know, 1 year, and then actually Dr. Senoro recruited me. But that time I forgot that some of the indicators does not make sense. No, for example, it's actually the volcano. For example, volcano experience. Yes, there is there is a one big volcano in Marinduque. I forgot what's the name. It's in Torrijos. Okay. Anyway, and then the volcano. For example, the number of how is it that of volcanic experience and a number of serious flood during the past 12 months. Of course, everything will be 0 in here. So the way we select the indicators is, that time the reviewers say like the way you select the indicators, it does not make sense because there is one is actually 0. Of course, later on the effector loading will be 0 because no such effect. Of course, the effector loading will be 0. Then that time I was kind of, I did not measure carefully, but this one is very important. So perhaps, Ma'am Gumasing, if you can make it everything equal, because you make
the better.
Yeah, perhaps you better. But if not equal, then perhaps it's okay. We can just do multiple linear regression. That is actually yeah. Okay, so this one. Okay, don't worry. Sorry, it's not duplicate. I choose the wrong. What's that?
Sir Yogi, question, sorry.
Yes.
Sorry, they must have an equal number of scaling in the Likert. But sorry, I'm not sure if I understand correctly. Do we need to set it up that in such a way that you will have the same units? Or
not necessarily. No, not necessarily.
Not necessarily.
But, for example, for example, 1%. Yeah. So as long as we make it into pre-processing like Likert scale like that one, that's fine. Yeah.
Okay, as long as they're converted into a Likert scale, so the units will be the same already because we're using already the Likert scale 1 to 5.
Yes. It's actually normalized the data, ma'am, because it's not fair, diba? Because it's just only 10, and then another one is like 1,000. It's So it's not fair to compare that one. So that's why I decided to like, oh yes, I forgot about that. So I borrowed the concept from the data mining. It's actually data pre-processing. We make it like that. So we normalize the data like that one. Yes, we normalize the data like that one.
But Dr. Yogi, the best way to divide your data into a rubric scale, let's say 1 to 5, is to frequency distribution table, right? Like get the lowest data should be the lowest scale, then the highest is the highest scale, then divide in between, right? Because there are some analysts who are asking why we divide it in that way. But it's the normal way, right?
Yeah, that's the data pre-processing. What will
be
the
I don't know.
What will be the way?
RRL.
What would be the
probably, sir, if they consider the frequency, like sorry, if you have, for example,
that's the normal way, right?
Yes,
but it's the normal way.
Yeah. It's the normal
but
way.
What if you have
but some panelists who are asking why is that why is that the method? Why not use the RRL? I don't know what RRL are they talking about. Let's forget about it. Okay, just want to confirm.
Anyway,
sir, but what if they have specific like sorry, like what if they have in the data you can see the for example multimodal data wherein there's specific points wherein it has at the highest mode. So probably you can use that also
Yeah, even
creating
so.
another
Yeah, even so we check the let's say mode, right? When you say mode, but even so there is always a range, right? The mom later on there's always a range.
But what if, sir, for example, we have 5 modes, but if you use the frequency distribution, the first 2 highest mode is included in just one group. Sorry.
Then
You
it's
get
just
it?
only one data then. It's only one, no variability then if it's like that one. Diba? It was there should be variability, because if there is a range, we basically the concept is just splitting the range into 5. That's all.
Okay, sir.
So there should be a variant. I mean there should be a data. I know you actually, what if we make it like 5 later on? It's just only 5, everything is just 5, something like that one. But then the way you divide the cut perhaps is a problem. So perhaps it's we always put the maximum minus the minimum, then we divide it into 5. Always.
Yes.
Always. There's
Okay,
always
just the
So Yogi,
frequency.
what's again the term? What's the term again?
Data pre-processing.
Data
processing. You will learn this one more in Dr.
Okay, data
Terra's
okay. Thank you.
yeah, data pre-processing. Yeah.
Okay.
We before doing any kind of for cluster and then later on decision tree and so on, and that's her expertise is not my word. So they always kind of like cleaning the data, something like that one. The same thing with what I'm what I did with the Marinduque data, because at the beginning, of course, it's not normal, and then when I read the comments of the review, I'm kind of like, oh my god, there was no one actually realized that it was a big problem. I was like, oh okay, then well, it's published already, so it's fine. Okay, Ma'am Bores, any other questions?
Nothing, sir.
Okay,
Thank
so
you.
far okay.
Yes, sir.
Okay, so that is okay. Then later on, we can have this one, right? In SCM, we can have the direct, indirect, and total effect. But for example, not always direct effect plus indirect, it will be plus in here. For instance, this one plus, and this is minus. Later on, the total effect will be a little bit lower. So the total effect of this one. So later on, we can see the direct effect, the indirect effect. And for instance, like this one to the symptoms, let's say there is no such direct effect, but we can see there is a connection. Let's just like what I mentioned before, there is connection between this is, for example, this person has HIV, this is HIV, and HIV is actually, they are actually connected, something like that. Or there is the effect possibility for this person to this person, something like that one. But the funny thing, actually one BS student, let's say, okay, Maela, you know what? One BS student, this is quite funny. My BS student kind of like, you know what? For the p-value, they also added. I'm kind of like, sir, and you know what? Actually, the p-value is quite weird. And when I say like this is quite high, because this one, they say like, sir, the p-value is like the total effect of the p-value is this one plus this one. Like I'm like, no, it's not like that.
Yeah, it's different.
It's totally different. This one you have to check the software. This is actually you need to check the AMOS. The software. Okay. And the way you decide, for example, 0.140. See 0.114. It's difficult if this is significant or not. But if you check the p-value, oh, it's actually significant. So basically, it's that one. But now later on, for example, this one, this is 0.3, but the p-value is actually the p-value. This one, it's actually compared to this one, it's actually different, right? Supposed to be this one has a higher has a higher p-value because this one is actually lower. But if we see both are significant, which one we choose? You choose the p-value. You try to look at the p-value more, or you try to look at the beta more. Maela or Ma'am Bores? there is one question actually from the reviewer. Actually, something like this one. You check the beta value more, or you check the p value more if both are the same significant like this one. Maela.
I think I'll prioritize the p-value.
Okay. What about Mambores?
Sure. If it has the same concept with correlation, probably if they're both, and if they have both lower than 0.05,
Yes.
yes, in the p-value, more or less I have to check now the direct effect or the beta value.
Yes, correct. That's the correct answer. Yes, that's the correct answer. So Maela, be careful with your answer there. If you have this one exactly lower than 0.05, we don't check this one anymore. We check this one more. As simple as that one.
Okay.
Okay. It can be, you know, the reviewer kind of like challenge, you know, our statistical skill. I'm like, yeah, this is a good questions. Okay, if you know both are you know are lower than already lower than 0.05, then we actually check actually highlight the beta. Okay. Yeah. Gumasing, is it clear? Gumasing?
Yes, yeah.
Yeah, correct. Yeah, okay. Oh yeah, because Ma'am Rhea, the one with the statistic. Yes, I forgot. Okay, forget about that. Yes. Okay. Yes. Okay.
Still learning, sir.
Okay. Actually, for example, this is quite different. This is actually a little bit experimental data. For example, Ma'am, let's say, I don't know, Ma'am Gumasing conducted this kind of study or not. You change at the level of something and you would like to test it to the human. Have you ever tried to conduct that kind of experiment? Not yet, right? Like the repeated. So that's why there is not yet, right? Like for example, the stick is like 8 centimeter, 10 centimeter, and 12 centimeter to the same participant. Have you tried that one? Not yet, right?
Not yet.
Oh yeah.
I haven't done any experimental study yet.
Okay. Okay, Ma'am Boris, do you have that study before? Like you try one object, repeat different conditions, you know, exactly the same object. Do you have that kind of experience?
Sorry, sir, what do you do with the object? We have a design of experiment, so we do some experimentation. Like
yeah, exactly like this experiment.
If...
Exactly like this experiment. Exactly. So have you tried with a human? What did you measure? May I ask?
Sorry, sir, as I can remember, in the human, effect in the human, physical or their reaction. We just tried. Usually, sir, we tried, for example, effect of putting water at the base of the candle. Then you try to measure the time. If it will be like faster to sorry, or if it will be, what do you call that, sir? Sorry, with or without water, which one is faster to
but it's not necessarily to one the same human, right? I mean,
yes. Not
okay.
it, sir.
Okay.
For
So
humans,
actually,
I can't remember, sir.
okay, so actually another way that we can do for SEM, actually this one is I got a question from, for example, someone asked me, hey, you only have 12 participants, how come you can run at the SEM? Something like that one. But hey, you forgot that I have 12 different conditions for that one. So basically the data is 144. If you can see this one, the data is actually 144. And then this one is purely experimental data. So that's why the R-squared is high. You know, the R-squared or like the model fit is extremely high. This is actually the experimental data. But if I conducted kind of like subjective, non-experimental, usually it's not that high using the questionnaire. For example, Maela, you know, participants, this one, they evaluate icon 1, they evaluate icon 2, they evaluate icon 3, and so on. So basically, even if you only have 12, but later on, the data, the y-axis is actually quite a lot. If you try to repeat, you know, the experiment using a different, how to say that, setting condition. You got it, Maela, here?
Yes po.
Yeah. Yeah. Don't worry. Next week I will go to the purely experimental. So later on, everyone will understand what is a ANOVA and what is repeated measure ANOVA, because repeated measure ANOVA is it's common in the experimental ergonomics, either cognitive or either physical. Usually it's very common using the repeated measure ANOVA. Okay. Later on, everyone, we can show the model fit. Of course, this is NFI, TLI, CFI, GFI, GFI. This is exactly like R square. This one, of course, when this is high, you can make a higher cutoff. But if it is low, you can make a lower cutoff. But usually 0.8 is the lowest, usually for the journal. But one reviewer kind of attacked me, for example, hey, your GFI is low, 0.8, you know, and I just defend myself. I kind of like some studies, okay, they use 0.8 for the minimum cutoff for the GFI and AGFI. Okay, so this is like R square. This is like adjusted R square, and usually the difference between the R square and the adjusted R square is less than 5% or less than 0.5. So that's indicating a good model fit. If it is higher than 0.5, then usually it's a perhaps, you know, we still can enhance the model and so on. But usually it's very rare for us to show the p-value for chi-square in the experiment, sorry, in the social science or in the consumer behavior. Usually it's very rare because usually people will not achieve this one, because I could achieve this one only because this one is experimental cognitive ergonomics. So that's why in here the p-value for the chi-square is higher than 0.05. This is very rare. So it means like there is no significant difference between the model and the data. But usually people do not report this one. People only report this one. Of course, this one too. Root mean square error of approximation also. Usually people show this one too. 1, 2, 3, 4, 5, 6. Usually 6. This 6 is actually a standard. Okay. So this one, of course, the lower the better. This is actually the higher the better, of course. Any questions for this? Oh, this one is actually affected by this one affected by the number of the participants. Of course, this one is actually affected by the number. So many things, you know, in here. In here actually mentions so many things that this is like politics. You know, this is like politics. It's like the effect of the sample size also affect this one. The effect of the model, actually the how complicated the model, it will also affect this one, and also about how good the reliability and how we say that the normality usually also they, you know, will affect this one, and the type of the research. The type of the research is also will affect this one too. Yes, Ma'am Gumasing, what happened?
What is the minimum number of data to run the SEM?
Usually depends, ma'am. Usually depends on what kind of the experiment. Okay. I have yeah, depends, you know, but usually it's not the participants. Sometimes, you know, for example, this is just 12 participants, diba? But
Okay.
yeah, but how come this one only 144, but it has a good model fit? Because this is experimental cognitive. But if we use some kind of like questionnaire, usually 250, 300 usually is already
100 cannot be.
100 I don't know. Well, but we can go. We can try, of course. Okay. Of course we can.
As long as it's as long as it will
as
pass
long as the model
this.
fit. Yeah. As long as pass.
Question, what if my data do not pass one of the measures?
The model,
like,
one of the
yeah,
parameters. Like,
so it must pass all this one.
No.
1, 2, 3, 4, 5.
No, be like politicians, hide it.
Okay. So what is the best measure
For
the
me,
fit?
For me, you know, whatever. Okay. For me, I usually show this one: GFI, AGFI, and then these three.
GFI, and the incremental.
AGFI, AGFI, and these three, and FI, TLI,
Okay.
TFI, and so on.
Okay. So what if my data do not pass one of these? Like, for example, out of 5, only 4. I'll just hide it.
Yes, ma'am. I usually just hide it.
The data or the model or my data will not be used for. So I can just hide it.
I usually just hide it. Yeah.
I usually just hide it. Ella, did you hide something in your model? Not really, right? I think you pass it, right?
You pass all the things, right? Maela, in your model. I
Oh,
remember your
yes.
model was fine. But your GFI is just around 0.
But it's
something, right? Yeah, it's still okay.
yes, my GFI is actually a bit low. That's why I showed the badness of it index because
Yeah.
I have extremely low values for that.
Yeah, it's okay.
So that's what I reasoned out during the
this one
defense.
This one is like R square, mom. It's also about politics. You know, some journals you can see like
yeah, it's this one is usually also politics involved. So yeah, as long as we can have, for example, I think the most
nowadays, mom. Nowadays, you know, we don't really put emphasis on this one. Usually, like nowadays we put emphasis more on the idea of the research
or the model construct. Actually, that we are competing in that one nowadays. So don't worry. For example, this one is low, so we should be inferior without no need. It's okay. We can try. Yeah. Yes, Ma'am Boris. Anything? No.
Sir Yogi, sorry.
Yes,
Based from Janice's question.
Uh-huh.
Sorry, sir, can you go back to the previous?
Okay, sure.
Previous slide.
Okay, sure.
Sir, for this one, we're just using, for example, limited number of participants. Then, you have the dependent objective variables and subjective. Usually, sir, for the subjective part, will it be affected by intervening variables like the learning or motivation or the tiredness, or like, for example, for me, sir, for example, for the eye clarity, for example, I've already seen it, but my eyes are tired right now since I already know for example, the letters in the, what do you call it, sir, yung eye check-up. So even if I can't see it, since I can already remember it, will it be affected by, since you're using the same participants, right, sir? So
this one, there
will
is a
it be
screening map.
affected?
There is a screening
yeah,
map. Yeah, we actually, before this one, we screen the participants. It's actually
okay.
quite, it's actually quite very controllable for this one. And then we actually randomize. We randomize the sequence of this one. So there is no effect of the sequence. You know, it's like,
Okay, sir.
that's
Like
why we make it the one
learning
first.
or...
Yeah, learning and so on. We randomize it.
Alright, sir.
Yeah, we randomize
Just to remove
Yeah.
that variable.
Yeah, to
Okay, sir,
minimize
thank you.
to minimize the learning curve. So that's why when I was
one of the panel members in the PhD in the computer science, oh my god, like Maela, do you know what? I was one of the panel members of the PhD in computer science of someone.
she was in her 7th year. I was kind of like, wow, 7th year. I'm like, and when I checked the PhD in CS, it's just one journal, I think, and it's not supposed to not to be SEI, but for us, it's the hardest. You know, it's like to SEI the first name. You know, but when I become one of the panel members, I just asked a very one simple question because she actually wanted to produce a sensor that can detect it's actually a sensor using the data mining. And so of course, because we are from CS, sensors that can predict your musculoskeletal disorder, something like that. So it's when you attach that one, it shows you that you are not ergo friendly and so on. But during the data collection, for example, people from CS, they always good at data processing and so on, and then they use the decision tree and so on. But I just asked one simple question actually, because they collected this in 2 different settings. One is like how is that, wrong posture, and one is correct posture. So from wrong posture, you collect so many sensors, you get so many data, and from the correct posture, you got also from the so many, and they also have the physical therapies and so on. But there is one very big mistake. I only asked one question, but I think that question, she almost cried because of my question. I apologize, because I don't know. It's just a spontaneous question. It's actually the question is, it's just like, hey, did you randomize the sequence And then she just mentioned, oh no, all participants started with the wrong first, and after that they start with the correct one. Then I was kind of like, oh my God, there is the effect of sequence. That if it is like that one, there is a learning curve, there is and so on. You know, perhaps the sensors, the data that she collected is actually because of the effect of the sequence. But if you make it like, okay, the first one for participant number one, the first one is actually correct posture. Participant number two, the first sequence is the wrong posture, and so on. So you have to randomize to minimize the effect of sequence. You know, if there is effect of sequence, then you know the data. I was kind of like, but I only say that. Oh, but mom, you don't need to. I don't suggest to recollect the data, but if we put that one in the limitations, then in ergo people, that's very unacceptable actually for the sequence effect. So sequence is actually very important, and sequence and learning curve for the experimental cognitive ergonomics or experimental physical ergonomics. Okay, so that's why there was a time when I made a mistake like that too in front of Dr. Jody, and he was so angry. This kind of like, and so like, you almost graduate and you forgot to randomize down. Oh yeah, you have to recollect the data again. I'm like, okay, then I recollect the data. Okay, Ma'am Boris, is it clear? Yeah.
Yes, sir.
Yeah.
I just want to clarify because I think that's one of the problems if you have the same participants.
Yes.
Yes.
We randomize this.
The intervening variables, sir.
It is.
Okay, thank you, sir.
Yeah. Ma'am Gumasing, any questions regarding that one?
None so far.
None so far? Okay. Okay. So for this one, it's always like a politics. You always can negotiate actually for this one, with which one you would like to show. And you know what, Maela, sometimes, you know what, one good paper, it's like 0.7, everything here 0.7. Sometimes me with Artin Ong, we kind of laugh. I'm like, oh my God. And then, you know what, this one, the suggested cutoff, you know what they wrote? You know, approaching to 1.
Yes.
So I think you saw it, right?
2.9.
Yeah.
Yes.
It's like, so everything is just approaching to 1. 0.7 is approaching to 1. So that's why when I, you know, that's what me and Dr. Satria, I'm kind of like, oh, you know what, Dr. Satria, there is this kind of publication. Wow. Okay, interesting. Okay. Okay, this one we can always play like politics. Okay, negotiate and so on. If one journal is like it, another journal will perhaps can accept it. Don't worry, you know, in ergo, Ma'am Janice, don't worry, you know, actually all the levels of your publications can be accepted in Word. Word is SCI. Yeah, all of your studies is actually can be accepted in Word. And Word is actually not difficult for the getting the acceptance from Word. It's a free journal actually. We can talk with during your individual session. Okay. Now, why the title is a confirmatory factor analysis instead of structural equation modeling? The reviewer also disliked. At the beginning, the title was not this one. The beginning of the title was like structural equation modeling of vulnerability to natural hazards. But they say like, hey, basically, okay, your model, there is no causal relationship. It's just high degree of correlation. If there is if this is actually just the high degree of correlation, there is no exogenous, no endogenous, then the name is just the confirmatory factor analysis. So that's why the name, this one is actually CFA. CFA of what? Something like that. Basically, is that one. Is it clear, Ma'am Gubasing? Just the term.
Yes.
Just the term. Okay, Ma'am Boris, clear? See, just the term.
Yes, sir.
Yeah, there is no X and Y. That's why it's like that. Okay, this one is like, this one, sometimes people show it like a square, but actually we can make it, in general, we make it oval, you know, because square is, usually people see this one as indicator, but okay, this is actually the latent variables, okay? This is the endogenous, so far there's error, and you can see the beta coefficient in here. What factors affecting what this one? A flood, okay, about the flood, and so on. And then intention to participate in flood prevention activities. Okay, measured by this one. This covariance, should we show or should we not show? It's up to you. You can show. You no need to show, because people usually do not really analyze this one. People care more about this one. So it will be like this one.
It will be, this is actually later on, you can see the standard loadings. This is the fractal loadings or the standard loadings, okay? Everything is here is maganda. Yeah, this is actually quite good, higher than 0.5 and mostly actually higher than 0.7. And then later on, there is a CR. Not the comfort room, okay? Some of the MEPI students say like, sir, what is comfort room? Like, no, of course, this is composite reliability, okay? This is what we call composite reliability. We would like to check the reliability of the indicators or the reliability of the latent. So in here, it's actually quite good. The reliability is higher than 0.7, the reliability. And then how we measure the reliability? Okay, let me just stop the share screen. Let me show how we measure the reliability for that one. Okay, let me. Okay, Myla, this is new for you. Right? So in the future, you can run it by yourself.
Okay.
The formula is actually, this is the formula. This is the formula. See, you can see like lambda, right? In here, the lambda. So everything in here is actually affected by factor loading. So this is actually always affected by the factor loading for the composite reliability. Okay, so although my publications of COVID-19, people attack it because of the, I did not measure the reliability and so on. Hey, I just replied to this one privately, okay, with someone who asked me the questions. My factor loading is still high. Actually, all the factor loadings actually are higher than 0.7. So yes, I did not measure this one, but even if you measured that one, it was still higher than 0.7 later on, okay, eventually. So how we calculate is actually like this one. I have the format. You know what, Maela? This is actually the factor loading. Okay, this is actually the Excel format. So you just type it, and later on you can get the value. I already have the format actually. Actually, I already have the format. Okay, so this one is actually just like this one square. That one is actually the square of this one, the square of the factor loading, right? It's actually later on I have to divide it by this one plus this one, so it's going to be like this. Okay, for example, there are 3 right in here. So don't worry, okay, everyone, mom, about this one. Just put the number in here, and later on you can get the factor loading. For example, but if you have more than 3, okay, later on, for example, you have 4, you have 5, you have 6, and so on. You just change this one. For example, change this number. For example, you have more than 3, you change. For example, you have 5, then later on you can add 5, and so on. I already have the format for everyone. And then later on, it's actually 1 minus this one, and then we got the composite reliability. Actually, the basic concept is actually from this one. But another term, perhaps someone said like, sir, why don't you just do this one? For example, with where is it? This one, reliability test. So later on, usually, okay, later on, usually in the paper, we show 3 things. Later on, usually in the paper, we always show 3 things for the whole paper. Those are, wait, let me open my paper. Which paper is good? Sometimes okay, let me just open this one. Let me open this. Wait for a while. Don't worry, that's just a technical. I can run it. For example, sir, can you help me to run the how do that? Can you help me to run the composite reliability? Yeah, it's okay. It's easy. Myla, I've done yours, right? Your composite reliability, right, for your paper. This one. Okay. This is actually we have to show this one, AVE and CR, but no, these 2 is actually extra requests from the this is actually I don't know, actually, honestly speaking, this is actually go to Dr. Satria if this one. I only know these 3. Okay, Cronba alpha, and then this one average extracted AVE, and also the composite reliability. So for example, this one average, for example, AVE and then CR is actually, you got it from the one in the Excel, the one in the this one. This is AVE and then this is CR. So usually I show this one per Latin, and this is actually also per Latin, okay, for the CR. But for Cronbach alpha, actually this one is actually from SPSS. This one is from SPSS. How I run this one? Okay, let me show. Let me demonstrate it to everyone. Where is the old file? Okay, I always keep the file. Wait, I'm opening the file. Okay. It's actually, let's say this one, okay? U1 until U7. So what is the Cronbach alpha from the U1 to U7? Yeah, of course we can do it, right? We can just this one, reliability test. Then we have this one, U1 until U7. We do it manually one by one in this one. And then we got the result of 700, this one, 0.833. 0.833 is actually pretty good. So 0.833 is actually the one that you see, this one, 0.833. Okay, and then this one is actually for this one is actually, but actually Cronbach alpha itself is actually already enough. Cronbach alpha usually for this one, but people still want to put these three. It's like, I don't know, it's kind of like a standard or story. Perhaps Dr. Satria can explain it much better. But this one you got it from SPSS. This two is actually we calculate by ourselves of the composite ability using the equation method. Maela, any questions? Because you're still processing, right? You kind of like still processing it, isn't it?
Yes. Can you repeat how Cronbach's alpha is calculated through SPSS?
Sure. So remember, let's say this one, okay? P3. Let's say P3, okay? This is under one Latin, diba? P3 1 2 until P3 7, right? So later on, you click analyze, and then scale reliability. This one. And then we at the P3 1 until P3 7. And then this is okay, just click OK. So later on, you can get 0.667. It's actually still okay, 0.667. Huh? What happened? Is it a mistake? Huh? What happened? I have to call Artfin. Artfin? What happened? What happened? Or I make a mistake? Wait for a while. Analyze, scale, reliability. No, it's correct. Or perhaps I'm opening the wrong file. No, if it's the wrong file, why the U7 is actually quite okay. But anyway, that's the way how to do it, actually, Maela. You got it again? This one, right? Analyze, scale, reliability. Yeah, it's correct. What happened with that one? Okay, let me talk to Arvin on later. But anyway, you got it right, Maela, for this one.
Can you show the result?
The result? Oh, the result is here.
Yes, the result.
This one. This is the result. Cronbach alpha 0.833 from 727 participants. Yes. You got what I'm talking about.
Okay, right? I saw it. Okay, thank you.
Okay, Mambores, any questions? Mambores, any questions?
I think it's lagging. So.
Okay. Ma'am Janice, any questions? Ma'am Jenny, still processing.
I can see the data that you're actually.
Can we use the Cronbach's alpha in Minitab?
Yes. Yes.
It will give us the same result, right?
Exactly, same result. We can do it too.
Yeah. What if one of the factors has low Cronbach's alpha? So what we will disregard that factor? Like, for
Oh,
example,
yeah.
intention to prepare as low as below 0.7. The cutoff is 0.7, right?
Politics. We can say like
Ah, okay.
approaching,
So,
difficult.
but if it's very low, what will we do? We'll just disregard the factor
Yeah,
and
remove
remove
it.
that?
We have to remove it. Yeah,
Ah, okay,
we
okay.
have to remove it. What else we can do, ma'am, if it is not reliable?
But if it's like 0.6, I always say like,
Oh, it's because of
That's
but it's
why
already, yeah.
the factor loading is a requirement, or we have to do this first before we perform the SEM, right? Or we
Yes.
can
Yeah, that's actually a very good question too. Usually people from public health, they always try to see the reliability first before collecting extra huge. But for us in engineering or consumer behavior, we just like, oh, we can take care of that one later. So
okay.
that's like,
actually I also realized that one. I think just recently, like when I published something about the health related or psychology related, then they kind of like, oh, you don't do the kind of pre-test, something like that one. I'm kind of like, no.
so I just,
Okay. Okay.
but anyway, ma'am, the best one is actually we conducted at least 50, and we actually checked the Cronba alpha from that 50 participants. If the value
Okay.
are quite good, I think it will be fine. If we
Okay.
analyze,
Okay.
Yeah, that's the
So no
no,
need to
yeah,
get the entire data.
yeah,
Just
no,
sample.
yeah,
so that's why now I become a little bit different, different from 2 years ago perhaps, because 2 years ago I didn't know that one, but when I talk more with people from psychology and from people from health, now I always say like, okay, 50 first, and then let's check this one if the Conver alpha is actually quite great. I haven't run the SEM, right? So this one is actually quite okay, then I make it into like massive. So I'm a little bit different, like somewhere in between. Not like people too much on the consumer behavior, like they kind of, it's okay, we will run and we will see later, we can remove this one. But all people from psychology or people from medical, they're so strict. They're so so strict. Look, only making one nice Latin. They're actually very strict in the health belief model, and so they're very, or people from public health, they're very strict in that one. But for me, I'm kind of in the middle. So I just say like we we actually run the preliminary reliability, and it's actually higher than 0.7. I only mentioned that one in the sentence thing. One sentence, and then the rest is actually I show it like this. Okay, any other questions before I move? Yes,
Dr.
Myla.
Yogi, can you
Mm.
go back to the composite reliability Excel file?
Yeah. What happened?
The values within the matrix are our factor loadings, right?
Yes, factor loading. This is factor loading. Just
How
copy the
about the power? The
the
power
power is
column.
factor loading square. This is factor loading square.
Ah, okay. And lastly, the E variance.
The E variance 1.1 minus this one.
Ah,
This one is
okay.
actually this one. You have to edit one by one, right? So like run by one by one. And this is one. It's actually divided by the average of this one. This is average, right? This is the average of the power, right? And then we have the E variance actually 1 minus this one. Okay, 1 minus this one, 1 minus this one, 1 minus this one. This is the E variance, and we have the composite reliability.
Okay, I got it.
It's you can see from this one the equation in here. So I just give it to everybody. I will just distribute this one to everyone. But the concept, if we go back to the calculus, but this one, just this one. If we make this one into Excel file, it will be like that one, the one that I share. Okay.
Okay. Thank you, Dr. Yogi.
Okay. Okay. So far, so good for this one. This is new, right? For CR for you, right? I did not discuss this one last time.
Yes, it's totally new.
Yeah, because if I explain so many things in details, like, oh my God, I don't know, how many hours my class.
Okay, let me continue. Okay, we still have a lot of things for this evening. Okay, this is actually the thing that perhaps Ma'am Gumasin can do for the next, how is it that, using all data, and we can try to submit the study in work is actually quite okay if the concept is actually quite fine, or the story is actually quite interesting, or the object is actually interesting. So just like the garbage collector, I think that one is actually very interesting. So if you still keep the data, we can rerun using the SEM like this one. So
But I only have less than 100 data or 100.
Word.
Wow.
It's okay. We can publish to Word.
Okay,
You
okay.
know, we can always
Okay,
publish
okay.
the study to Word. Yeah. Don't worry. It's not that complicated. Okay. And this one is actually this publication I published two how is it that methods. One is SEM and one is actually the using the, how is it that, using the multiple linear regression. But of course the result is the result different, most likely different or the same? Yeah, most likely the story the same. So it's a little bit like, yeah, most likely the story the same, you know, like that one. But I just would like to show that we can, you know, if you have the data, this is experimental physical ergonomics. If we have the data, then we can actually like this one. But the story of this one is actually the thing that I would like to tell to everyone, that even, for example, oh, male, this one is actually the story like what I've mentioned before. Male has the higher hand anthropometric, which subsequently, you know, lead to the higher grip strength. Yes, but what about this one? This one happened. It's actually like this one. If we eliminate the effect of hand anthropometric, just the gender itself, it's still significant. So it means like if someone has the same hand anthropometric, male and female, you know, exactly the same hand anthropometric, still male is still stronger. So the effect of the gender itself is actually has the effect of hand to the hand grip strength. And hand dominance, this one, actually I got attacked by the reviewer of, they say like, this is very strange because hand dominance is very, how we say that, you are too brave to say that someone who has the right-handed is stronger than the left-handed because your left-handed is not equal. They say like that one. This one is actually, you have to say this is perhaps just the random effect. Because when I say like, because at the beginning when I submit this paper, oh, this is to IEM. Yeah, IEM is actually quite strict. You know, the reviewer, one of the reviewers say like this one. No research, such research that really, you know, predict, you know, with the same sample size, left-handed and right-handed, exactly in the same sample size, and they say right-handed is stronger. At the beginning, I just say, oh, because right-handed is stronger because of this equation and so on. And this person kind of like, you are too brave to say like that one. Your, I would say your left-handed is just only few, right? It's just the random, the effect of so many random, it's just the random number. So that's why they say like, perhaps I have to change the publication. This one just the effect of the random. The grade, this is just grade 11, grade 12, of course, no significant difference, you know, and so on. So this is just the story. Yeah, of course, using, how is the R square? Oh, 70%. Yeah, it's still okay, 70%, and so on. Okay, now we can go to the some of the important models, but don't worry, everyone will learn this one in more details with Dr. Satrias, because this is actually close to the consumer behavior. About the technology acceptance model, theory of planned behavior, UTA, UT2, protection motivation theory, and so on. But anyway, yeah, the acceptance of mobile application is actually a hot topic. Actually, I'm doing with my undergraduate advisors the Stay Safe Philippines, the contact tracing application. For that one is a good topic, but the one that my favorite is actually I'm doing with one of my PhD students from Thailand, because in Thailand, you know what? No matter where you go, you have to use the QR code. Even entering the 7-Eleven, even just entering the any kind of building, you have to scan, you know, with the QR code. If not, then you have to get a ticket. You know, you'll be called by the police and so on. So no matter where you go, you need to do it. The same in here. We kind of start doing it, but it's kind of useless. You know, it's like what, you know, used for me is I don't think that is a good applications and so on. So acceptance of mobile application is a good topic. And then this is the research flow, actually the standard research flow from someone who wants to conduct kind of I would say that study that utilize the SEM usually that not related to the experimental. So this is actually the one that utilize the questionnaire. Okay, usually the questionnaire. So we try to utilize well-established theory. That will be much better. Later on, why we have to use well-established theory? Because later on, the factor loading usually is good if we have a nice theory. For instance, like there is one like theory of planned behavior, technology acceptance model, UT82 protection motivation theory, and confirmation disconfirmation theory. Yeah, so many actually. And then we specify the model. Okay, we see where is the new thing in our model. For example, like adding the COVID-19 prevention measures, or like vaccine. You can be one latent, or nowadays what else, like the competitors, as one latent. Perhaps that will be interesting. And then for the data collection, usually it's 250 for the for the 250 is usually is fine for the any publications, but of course the higher the better. But if it's 250, then it should be fine. I only know Amos. Actually, there is another one, we call it Smart PLS. I don't know how to use Smart PLS. If everyone wants to use the Smart PLS, Dr. Satria is an expert with that one. So I only can do Amos, and then of course we read the paper and so on. Okay. For example, this one, how I decide the minimum number of sample is actually by using this one. For example, this study 429, 384, 100, 188, 198 is actually quite low, and telematics and informatics, this is actually very great journal, but this is 2015, so it's already old. Usually 3 years is the 3 years is fine, but because the competition is more competitive nowadays, if 2015, yes, I think it's fine, but nowadays usually it's really 384, 429, and so on. And this is actually the latent that they use. So usually I make my mix and match. For example, this is the framework they use: the MI success model, extended technology acceptance model, ITM. I'm not Dr. Satria. Okay, you can discuss with him. Okay, for this one. Anyway, this is how I try to make the research cap, and this is actually helps me to really write the paper. This is the TAM, technology acceptance model. Oh, this is one of the widely cited papers. Okay, it's already 40,000. Yeah, 40,000 citations for this model. Okay, how actually the process someone utilize the actual system. Okay, so this is the standard. But if we utilize the term extended, then we actually extend the model. We add another latent variables. But is it something like my advisor, Dr. Jolin, he kind of like, how we say that? He kind of not really like, it is like the technology acceptance model, because he said like, oh, this is just a kind of like regression and correlations and so on. Yes, that's the basic standard concept of the SEM and so on. And if you check the original paper of the Dr. Davis, it's actually not as complicated as the one that published in 2021. 2021 is actually, wow, it's actually very people, I realized that the competition of using the TAM is very tough. Okay, this is actually the standard that he published. Okay, he utilized the Likert scale, and then this is actually this is just a simple one, but nowadays people try to extend, even more and more and more variables that they added into the technology acceptance model. For example, like this one. Okay, acceptance is different with the usability. I would say one part of the usability is actually the acceptance. But anyway, usability is actually about a comparison. So for example, usability study of blah, blah, blah. If the title is usability study of blah, blah, usually the study is actually comparing. Okay, comparing the A, B, and C to some participants, and they use repeated measure ANOVA and so on. That's usually the typical of usability study. Or like, for example, the effect of something, the effect of Google Glass, some of the Google Glass something to the eye behavior, something like that. So you actually manipulated some of the variables, and then you would like to compare. So usability most likely usually about that one. But
acceptance is just acceptance, how the mechanism, something like that. Look at this one. Driver's acceptance. See, the title is just the driver's acceptance of mobile navigation application and extended TAM and so on. So this is the title. This is a good journal. See, this is the standard. This is actually Latin. Okay, this is just a Latin. Okay, and this is the external variables or the extended variables that this study use. Okay, so it's actually like this one. So when we utilize, we would like to conduct any kind of a study, like acceptance and so on, it's better for us to utilize a certain theoretical foundations, certain existing theories, to before distributing the questionnaire, because later on this one is already well established theories, so you don't need to like do exploratory factor analysis and so on. So instead, we just do confirmatory factor analysis like this one, or like the SEM like this one. It will be much better. Actually, it's not that difficult. Look at the questions. It's not that many actually. Maela, don't you see that this one is actually not really, it's actually not many, right? This one, right? Not
Yes,
difficult, right?
just few indicators.
Yeah.
But the model looks good.
Yeah, the model looks good. And also, this is a good
Mhm.
journal too. I feel like HCI journal is that one is actually one of my favorites journal. Okay, this is actually one example that you can use. Another one, look at this one. Acceptance of mobile library applications. Okay, an extended technology acceptance model. See, this is just by only looking by the title, we know what this study is about. Only just the title, we know what inside kind of guess inside. See, extended TAM. So see, this is the Insignia is the perhaps the name of the what's that, mobile, okay, mobile library applications. This is how 2020, okay. But nowadays I already published so many things with the learning management system, and I think that topic is already not, how is it that for example, like Blackboard and so on, usually people are not really interested in using that one anymore. Nowadays, people goes to like contact tracing application, or like I don't know what else, dating application. But I don't know. Dean Young said that, hey, you cannot do that kind of research. Yeah, okay. Like the certain behavior of acceptance of kind of a dating application, or like Twitter, TikTok. Actually, I would like to try TikTok, but I think someone already published it. I don't know, and so on. But anyway, the best thing, if we would like to have this kind of topic, is actually a disaster related that only happened in the Philippines. And the respondents is always just the Filipinos, and you actually competing with no one. Usually that research is actually easy to be accepted in a good journal. So but now I think we don't have application right in the Philippines to detect something like earthquake or so on, mobile application, so this is another theory. Don't worry, you will learn this one more with Dr. Satria. The TBB, another one, theory of blend behavior. It consists of attitude, subjective norm, perceived behavior control, intention, and the actual behavior. But of course, we can always make it another term. We call it extended TTD. Okay, so we add into more and more, because that the term is actually extended. Okay, and then the questions under the Latin is actually you can always make it, you can always modify it. Okay, you can always modify it, the questions, the statements, I would say, under one Latin. For instance, oh, this is just very simple, right? Look at this one, Maela. The model is just like this one, green consumer identity. And then attitude, subjective norm, this one, to purchase intention. That's all. This is very, yeah, right? This is very simple, right? Look at this one, right?
Yeah, simple.
Yeah, this is actually very simple. But that one is actually not my topic. The green, I would, because I don't know. Nowadays, I just would like to go back to my track ergonomic, the pure track, okay, ergonomics. But nowadays, I being dragged by the coffee to go to consumer behavior. But now I'm trying, myself to go back to the ergo, because if I do this one, then it's the consumer behavior study. But of course, macro ergo is actually, some parts of macro ergo is actually consumer behavior. But I would like to go to my, my path a little bit different from Dr. Satria. Okay, and this is actually from protection motivation theory, and I combine it with a theory of planned behavior. So this one actually from understanding COVID-19, it goes to like perceived effectiveness. So there is a connection that someone who keep updating, someone who keeps updating the knowledge related to the COVID, actually that person is actually more effect to the perceived effectiveness, because this is the mechanism. You understand the COVID, you feel afraid and feel vulnerable, and it triggers you to behavior. But when it triggers you to a certain behavior, it goes to the theory of planned behavior, right? So it goes to this one: perceivable control, subjective attitude, intention to follow the safety protocol, and then your adaptive behavior, actual behavior, and eventually it goes to the perceived effectiveness, like this one. So it looks like, yes, this is like complicated, but the story is so simple. Actually, the logical story. And I was in rush that time to publish this one, because if you are the first person who publish this one, then usually the citation is high. Yeah. This is I did. Oh yeah, with some of my friends here. This is actually the online food delivery, the Grab, okay, the application. But this one in the Grab, I have so many latent variables at the beginning, but eventually the result is very interesting. This is actually the citation is actually quite good too. This paper I just published in January actually, or February. This one. Look at this one. Actually, I prove it that the usability things in the Grab application is useless. I actually, at the end of the paper, I stated like that, So the investor or the developers of the online food delivery should not invest those things to make the applications more usable, to make it more user-friendly and so on, because it's useless. The thing that is significant to enhance the actual use and satisfactions are actually just the hedonic motivation, information quality, actually this one, information quality of the discount, the price, and the promotion. See, so people already get used to it. You know what? How to use the mobile app. So we should not invest to the, another thing I add in here is actually safety packaging. Safety packaging not important when someone use the online food delivery. People care more about these things, the hedonic, the information about the discount, and the price itself. So this is the unique thing that I found a little bit different with some studies that who mentioned that, usability is important, perceived ease of use is important. No, I prove it. I found it that those things were not significant. So for the policy implications, you can read the paper in MDB actually. Actually, I stated very clearly and very straight for a while. Wait, sorry. Okay. Sorry, wrong click. Okay. And then this is the last model that I would like to mention. This is the UTAUT2. Okay. UTAUT2 is actually another model that we can use when we utilize a certain technology. This is actually related to the technology. They name it UTAUT2 because this one is actually from UTAUT1. But don't worry, Dr. Satya will explain it in details. But in here, you can see the standard latent. It performs expectancy, for expectancy, social influence, facilitating conditions, hedonic motivations, habit, and price value. Okay. And then this one, don't worry, you can always extend it. For example, extend it UTAUT2 and so on. You can always add more and more latent, in your model. Oh, this one is very consumer behavior. Okay. I hope that it's okay. I'm not saying no, but if you like to use the surf call and then to the satisfaction and so on, yes, SEM can go to that one, like the tangibles, reliability, responsiveness, assurance, empathy, and so on. Of course, this one can be, but this is by Justin, yeah. because this one created by EPIE, so it should be company study. But I just added a strong theoretical background. So he collected after sales. So the one that came to the Toyota in his company, kind of like after sales. And later on, we can see actually empathy is actually the most important. So, the empathy, so people can go back, to go to his company to have after sales service. And this one, you know what? This one actually no theory. So that's why this one got rejected for so many times. I opened the story of this study, okay? This one, no theoretical background. I just put the path and so on. And I don't know how it was, how it got accepted. I think I got lucky, in this journal. So this one I created not by, how is that, a strong theoretical background. I just connected questionnaire with another questionnaire. I just randomly put that one, and this is actually the no theory. So that's why when the paper rejected this one, they always say the same thing. This one is actually not supported by a strong theory and so on. But well, I did not give up. The writing is actually quite good, although like it's difficult, to when I see this one, I'm kind of like, hey, what kind of theories you use? This is very consumer behavior, It's not like experimental cognitive ergonomics or physical ergonomics. If that one we can define that it's fine, you can defend that it's fine. But this one, it's difficult because this is very consumer behavior. So, but what else we could do, because we collected the data already and we realized that no strong theoretical background in this one. Okay, so this is the step from Excel to the SPSS and then SPSS to Amos. Don't worry, for Mam Gumasing and Mam Boris, later on, if you do not have the Amos, I can give you the link. We can install it anywhere. If you don't have the SPSS, I can give you the link too. So if Minitab you don't have, I also have this installed for Minitab. Don't worry. This is fine. This is fine. This is fine. Oh yeah, I also would like to ask, I don't know, Mam Gumasing and Mam Boris, this is quite a dilemma too for me at this point. For example, I don't know, when the students graduate, I work alone. It's like, I don't know how to, but I cannot push the students too because it's not their level. They're not the PhD students. But at the same time, I'm kind of like, at this point, I have so many papers unfinished. I mean, it's already maganda, but I need to work more to make it too detailized. But usually, like, I work alone. Now I feel I don't know. I'm kind of like a little bit demotivated to some topics. Then I would like, if I did feel demotivated, I just submit to non-SCI journal. As long as it's journals, Scopus journals, it's fine. But I don't know. What do you think, Mam Boris, Mam Gumasing? Any tips that? But I cannot. It's difficult. I don't know how to that one. I feel like it cannot be like PhD student. Like, oh yeah, because PhD, like you have to have to SEI and then you graduate, right, and so on. But they have limited time, so I don't know what should I do now. And I cannot talk to how is it that Dean Young also, like, yeah, I also have no solution for that one, So any idea, Mom? As advisor.
Sorry,
like,
Dr. Yogi, you're lagging. You're lagging. Sorry.
Sir, we don't have that, I think, level of study yet. But for undergraduate, we have, I think, 9 months. So 6 to 9 months, so probably they have enough time. For my master's students, sir, usually if I give them incomplete grades, they can actually finish it in more than 5 or 6 months.
But yeah, but a journal sometimes, like, sometimes the idea is beautiful, Mom. But when I ask, hey, we need to add this one and that one and so on, and they disappear.
But they already graduated, sir.
and then Mom Gumasing, even worse, Mom. Actually, some students, I already submitted to ISEA, school already paid and so on. And when I ask during the presentation, they're gone. They
Ghosting. That's what you call ghosting.
I already email and so on. I mean, like, hey,
Ghosting.
Yeah.
I'm like,
Ghosting, yeah. It's very common in the Philippines. Ghosting.
I'm kind of like, hey, the presentation is tomorrow. I haven't prepared anything. And I was like, okay, calm down. Okay. Then I had to cover 4, mom. 4. So I created the PPT. I was the one who present, and that night I didn't sleep because I read the whole paper and check again to like, okay, now I understand the paper. and then and then and then one actually got the best presentation award. And after that, and then I okay, hey, congrats, you got this one. It's okay, I already covered this one. Don't worry, you know, you don't need to do anything and so on. And they replied quite fast. Oh, thank you, Paul. And so on.
Yeah, because of the award.
And then it's very funny. They replied very quick. I'm like, wow, you replied very quick after the conference. That's a dilemma. Anyway, well, it's okay. Well, okay, this one, mom. This is actually the thing. Perhaps Mom Gumasing and Mom Boris can start doing it. So actually, like this one, mom. If you have a nice idea, nice topic, perhaps from A student we can go to the A plus B. We can continue to the next one. A plus B plus C. But of course, they need to add another thing in their study to make their work so it can be distinctive. And then eventually we can go to a good journal and so on. So this is actually one way that I've learned from 3 advisors, because I was under Dr. Chi, Dr. Jolin, and under Dr. Bernat when I was in Taiwan. They actually had the same pattern. They actually try to give from A to B, B to C, and so on. So eventually that's why at the end, sometimes, you know, and the second student, for example, the model was not that good enough, but Dr. Jolene was kind of like, hey, I think we can add something. I still curious why the throughput. It's okay. Throughput you will learn during the Fitts law. When I explain why the throughput is low and so on. So I think there must be, we can add something, you know, and then the C student kind of replicate and change, add something, and the just like making the vaccine, okay, and eventually that, like, what you know, it's actually a good one. But the problem is the time. The problem is the time. I also sometimes like discuss. Sometimes I talk with Dr. Jolin. Yeah, of course, you're in Taiwan, you can do it, but in the Philippines it's difficult, you know, to do it. And then and then he just suggested me, well, at least, you know, then you have to be the one who cover until until it goes to this one. So the student perhaps only A, your B, C, D, E is like you. But of course you will be overloaded up to a certain point, you know, just like me at this point. You know, sometimes when I talk to Dean Young, I'm kind of like easily got mad because of like, hey, you know, I'm shouldering so many things. And so on. So that's actually yeah, the thing that I'm facing at this moment. Yeah, see, just like this one, I my publication with one of my best friends. Actually, I started with the journal, and then after that, when I use the the left behind data, I would say left behind data with the R square 20%. At least it's IEEE IEM. And then I submit to another conference. I got best paper award. I'm like, wow, what happened? I'm like, I'm kind of confused. Perhaps because I show, oh, previously we did this, with that study, that study. It looks so rich, but actually the one that I presented, it's actually just a very small lagging behind, you know, the small data that I haven't, you know, used and so on. So that's the logic. But it will be difficult, ma'am, if the first is actually the conference, and after that the second one is journal, because later on the journal, they will detect the similarity. I don't know. The journal, they have another software, not just Turnitin. They have several softwares that can detect, you know, how the similar our public, perhaps, yes, not the plagiarism, but perhaps the similarity. They can detect it, the similarity of the research sometimes, you know, and sometimes they show, hey, you know, this publication, you already published it in this study, so perhaps that's quite difficult. But if the approach different, it's still fine. Usually exactly the same data. For example, this one is repeated measure ANOVA, this is SEM, this is exactly the same data, but the approach are different. Okay,
then we still can publish it in still a good journal too. So, but the problem is, for example, the same SEM, diba? This is SEM. Of course, this one cannot go to a journal if I, sometimes like I make a joke to my friend. Hey, can I submit this one to a journal? Oh yeah, you can submit, but don't put my name there, because of course it will be rejected right away. The journal not stupid. They're like, oh yeah, okay, because it's exactly the same approach. What is new in that one? Only new one Latin in new, the rest is like the same, because it will be very weird, right? For example, this is the model, exactly the same model, and then you do one more Latin, you do one more Scopus in this publication. Maela, can you imagine? For example, this is your first publication is like the effect of subjective appetite to the menu options. That's one paper, and then the next paper, the effect of the menu options to convenience, vividness, and Maela, you don't want to do it, right?
Mhm. No.
I mean,
It's
yeah,
like we're lacking a bit of
idea.
the main sense of the paper.
Yes. So yeah, that's what my friend just like told me that joke, to me before. Okay, anyway. Yeah, we can do many things with SEM. Basically, if the way I got the research idea, usually I watch the news. I usually watch the news. So for example, there was a fire, earthquake, or taal or typhoon. I got those ideas is actually from the or like field health. The problem with field health, the problem with those things actually. I got it from the news. Usually, I got some ideas from that one. So yeah, choose the topic that you're comfortable with. But another one that don't be, I would say that afraid with the data that you have. Just there are certain levels of a journal. Let me show to everyone for Ergo. Okay, the level, it's not the level. I would say if one got rejected, we can go to another one. We can go to another journal. For example, the study that I've done with my students for a while. This one. See, it got rejected from 1, 2, 3, 4, 5, 6. Got rejected 6 times, and then I submit to work, and it got revised. Now it's almost got accepted. So, if one journal is like, I go to the next one, next one, and so on. So, sometimes it got lucky, like one shot, it got accepted, or like revised, and so on. So, but anyway, another one that recently got accepted. Look at this one, Maela. This is the the model is so simple. Or do you know my Taal publication? In the Taal, the model is so simple actually. Like, and sometimes people ask me like, "Oh, are you sure it's written by Yogi?" Like the model, the model was. Oh no, this one I need to show you the model, the figure. Okay, let me show you the figure. Okay. This one is very simple, but his writing is pretty maganda. Yeah, Lorenzo, it's actually pretty nice. Okay, so where's the figure? Okay, this one. Maela, only this one. The effect of organizational commitment.
Oh.
It's very simple, diba? And if this kind of publication can be accepted in work, I think Ma'am Gumasing can be so confident at this point. Like,
Really?
diba? Look at this one, Ma'am. This is so
Very simple. Or organization individual. Be accepted in work.
And no revisions. This one, no revisions. No revisions,
What?
but
No revisions?
no revisions. My first time in my life, no revisions. So, and then the question is very easy, you know. It's just like, okay, this one, and that one. So yeah, of course, but sometimes yeah, people just like it. But I think this one, you know, now I realize, you know, if this kind of publication can be accepted in the Word, then we can submit all papers in the Word, right? Yeah, I mean, if we have the SEI, the incentive is the SEI incentive, right? Ma'am Kumasig, no matter what, no matter what
Yes.
the model it is. Because, for example, ma'am, sometimes, you know, when I see this one, you know, I feel like, I cannot believe, you know, for so many times, sometimes like, only this, there's something. But ma'am, ma'am, the one that the one that I published in the Taal is the one that I published in Taal, but of course it's just the final exam of my class, so that's why like the model was how is it that the model was like oh, what kind of model that one, you know, but that one got published, and I was very shocked, like, and I'm like, how come, you know, that paper got, how come, I also cannot believe it, how come that paper got accepted in a night. And no, it's not just nice, it's a top Q1 journal. I also don't know. There are so many things that you cannot control actually in the PhD. Sometimes a good paper, yeah. Sometimes a good paper is actually the how is it that very difficult to be accepted, but very simple paper, you know. Only this one, ma'am.
Sometimes it's luck.
Only this one. Only this one. I also cannot believe it. Diba? Only one.
Very simple, yeah. And it has three indicators per.
No, yeah. Only this one. I'm like, so sometimes I make a joke, you know, with Artin. I say, hey, don't be too show up, don't be too high. You know what? Yeah, I know this is maganda and so on, but you're the same level with this. I mean, same journal, diba? I told you, hey, you know, it's the same journal, so you don't need to be. And then he always got mad, you know, every time when I make a joke on this one, because but this one, mom, why it got published is just the first study that analyzed about the Taal, the volcano, you know, after the explosion. Actually,
Because of its impact, maybe because of its
yeah,
impact.
because of the impact, people kind of like looking at that and kind of that publication. So that's why actually I did not get the idea. The idea is from these two. Yeah, these two girls. Yeah, they graduated, right? Okay,
Yeah.
from these two, yeah, from these two, they told me like, sir, I would like to do Taal. I'm like, wow, you have the sense. But that time, since it's just undergraduate students, I'm like, oh yeah, it's okay, you know, as long as you can collect the data and so on. But after the class, I kind of regret. I'm kind of like, this is the model. I'm kind of, but this is good idea. But I was kind of like, it's okay, I just submit it. And I was shocked. It got revised. So I'm kind of like, how come? I also cannot believe it. Like you know, this kind of model can be published in this you know, this journal. But anyway, we cannot control those things. What we can do is actually we can try our best to how to say that we can try our best to create impactful model. But I think that one is actually quite impactful because of the novelty, because the people wants to read actually what happened with Taal, you know, that time. And then the reviewer actually wanted to the reviewer wants to know what happened with Taal that time. Okay, so I still have last minute. Okay, I would like to tell about the second order. Okay, wait, let me just show. It's okay. This is actually a model by Ken, but perhaps this is actually very new for everyone. Maela, perhaps it's also new for you. So let me show it to you. What is second order? don't worry for running the SEM. Don't worry, everyone. It will be during their individual meeting. Okay. I can help everyone to run the model, but running the model is not difficult. The difficult part is like how you create the model. Creating the novelty of the model is so difficult. I would say like the novelty itself, it's so difficult. Okay, let me show you. Oh, I cannot. I would say that I cannot. Okay, now let me just show this one. This one. Okay. The idea of this one is a little bit different. Okay, it's a little bit different for second order. Second order, it happens something like this one. The problem of second order is actually these three. This three has no indicators. But this one, actually, you would like to divide it into a Latin like this one. Divide it to a certain Latin like this one. But this one, this 1, 2, 3, 4, you confirm, you know, this one actually under a certain Latin, a certain dimension. For example, can we remove this one? It goes to this one directly. It goes to this one directly. Yes, you can do it. But I would like to group them, this one into, because this one based on the reference, literature, and so on, it belongs to these three. So this is the time when it calls second order. This is still the why. For example, if I don't make this one, I just make the double arrow. For example, this one, the double arrow, like double arrow like correlations. This is like double arrow correlations. This is double arrow like correlations. Is it possible? Yes, that is also possible. The thing that I would like to highlight is actually this one, the Latin that under the Latin. So, you know, the Latin under the Latin. So that's why what we call the second order. Maela, so far okay? You're still processing, right? you
Yes,
get the
so
sense?
far so good.
Yeah, you got the sense, right? This one, right? So
Yes.
so later on, here it's different. The error is actually, if we would like to make the second order, the error is not in here. The error is actually in the second Latin. This is the first Latin, this is the second Latin. So the error is actually in here. So it's like making average of this one and making average. I mean, the simple basic concept. Okay, this is like average of this one belongs to this. This is average belongs to this, and you would like to make regression like that. That is the same concept actually. But we would like to see among those, this one, which one is actually quite contributing, you know. For example, SE and EC, you know, which one more important to EBS? Of course, the EC, you know. But among EC, COT is actually the highest effect, you know, followed by this one and this one. You can see you know, the connection. And then, for example, among all of these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which one is more important to this one? You can see two, but of course indirect. Diba, you can see like this one to this one. Yes, you can see, but indirect effect actually. You can see like this one to this one too. So running this is also possible, and this is what I call second order. Is it clear, Gumasing?
Yeah, but it's complicated.
Yes, but your case is second order, you know. Your case is second order.
Oh, really? Second order? What topic?
Oh, the one that I just
What?
found.
Oh, okay.
Don't you know that it's second order? Your case is second
No.
order. It's
No.
very rare, actually. No. This one is actually a little bit rare. In SEM. This one. Mambore's model is there is no second order. You know, it's like, but your model is second order.
Even the service quality, the it's right.
Yeah.
You don't realize, mom, it's second order.
No.
Okay. let me.
Yeah. Because of the social, economic, then service quality, right?
Oh, and surface quality there are.
Okay. Yes.
Okay.
Okay, so that's the second order. That's the meaning of second order. If you have
It is.
Yeah,
is.
if you have latent variables connecting to another latent variable.
Yes. Yes.
Yeah, okay,
That's
okay.
okay. I don't open
Okay.
your secret to everyone, but it's actually the concept like this one, everyone. It's okay. It's your topic, so I don't I'll say that, yeah, tell to everyone. But anyway, Ma'am Gumasing is actually like this one. Okay. Her model is like this one. Let me tell you why the name of that one is actually second order. Okay, it's actually very complicated. Actually, quite complicated. Using second order, but it since perhaps the data pre-processing is not that good. So when I tried this one first, the indicator is not good. So I realized that, for example, this is let's see this one. Okay, okay. I don't tell you what is this one. Okay, this is like, okay, x1, this is x2, and then x3. Okay, and then her model. Okay, everyone. Okay, just like let's say, okay, let's say this one. Okay, so sorry. So it's kind of like this, and then okay, just imagine, okay, just imagine, everyone, that she would like to predict this one. Actually, she would like to predict this one. Okay, but okay, before using the SEM, she actually utilized standard multipolar regression. But is it okay? Yes, that one, of course, it's still okay. But if you would like to make it the SEM, it will be like that. She would like to predict SQ based on the E, S, E, and Phi. Okay, okay, but SQ is actually no such measure directly with SQ, diba? Pang Gumasing? There is no, you don't have the value of the SQ directly, right? No, right?
Sorry, Dr. Yogi, my internet is lagging.
I think mine.
Sorry,
I think mine.
okay,
Anyway,
okay.
okay. The idea is like you would like to predict SQ based on these three, right?
Yes.
Yeah. But SQ, as actually there is no such value under SQ directly, right?
Yes.
So it's actually SQ is
Yes.
actually divided by this one.
Measured by the
Measured by
three
these three.
indicators.
Yeah, but this one is
Okay.
actually a latent create from these three indicators. So that's why this is the case
Okay.
when this is actually the second order.
Second, okay. Okay.
So this is the case second order. So when we see something like this one, like it's not the effect of SQ to x1, x2, or x3. No, this is actually absorbing the y, because this is like this is the x, this is the y, right? The y is actually this big, like in the regression. Yeah. So basically the concept is like that. So this is the concept of. That's why you're a second order. You did not realize that your model is second order.
No, but I already made the graph.
Okay.
Actually, I will show it later. But again, since it's not workable in SEM, so
yeah, it's
not. We'll just forget it.
Especially the one in here. I tried Ma'am Gumasing's model and all the factor loadings below 0.5.
Yeah, maybe because there are some indicators with a very low range. The answers are only from 1 to 2.
Yes, perhaps. Yeah. Perhaps that's the reason.
But I can give you another set of data, the satisfaction. Maybe you can try if it will work on SEM.
Okay.
I'll send it later.
Yeah. Maela, is it clear? This one? It's clear, right? You understand this one, right? The concept.
Yes, clear. But I'm just curious.
What?
If we will use the model with the model fit.
Oh, the model fit, what do you mean? Again?
Oh, what will happen with the model fit if we will use this second order model?
No, the same. It's the same with model fit. What happened? No, the same, the same. The model fit, like the indicators and so. I mean I was that it's the same. No difference.
Oh, but will it increase the values or will it decrease since we'll?
No, this is actually not really. This is the concept is like you make it like you think the model is simpler and so on. No. This is like if you remove this one, if you remove this one, right? If you remove this, it will be like you can go directly like this one and that one, and so on, right? But actually, she wants it to be in like this. It goes to this one as the meeting point of all of this. So basically, the model fit not really big difference with the standard SEM that you have done. Exactly like that. What do you mean with the different variants, different lower? I don't get it.
But what if there are indicators for that SQ?
Oh, if there is the indicator, then that is not the second order. It's just a standard SEM. You make it like this one, for example, like oh sir, whatever. If SQ is divided by this one, then yeah, of course it's possible. But that one is not second order. It's not the case of the second order. I'm just showing the case of the second order. This one. If this one, then this is the second order. You got it?
Okay.
Hmm.
Okay.
Okay, Ma'am Bores? Any still processing? Yeah, I know you're still processing.
Yes, sir.
Yeah, I know.
If we try
Yeah,
it,
yeah, I know.
I'll
It takes,
understand it better.
yeah,
Yes.
it takes experience also. No. You will grow by time for this one. But this is not a common not a common
Yes, sir.
thing. Just because Ma'am Gumasing's model is the second order, so I just have to tell everyone. And also Maela perhaps get bored with the SEM. Now I'm showing you more difficult level of SEM. This is actually the second order. Anyway, the last thing that I would like to tell everyone, for example, there is a multicollinearity effect. For example, this one is actually higher than 1. What will happen if there is a multicollinearity, just like this one? I have a multicollinearity case. This one. This one. This one. 1.07. What happened? 1.0 like this one. There are certain ways to make this one no multicollinearity. One of the ways, because this is too strong, so you can remove one of these actually. One of the ways to make it no multicollinearity. So if there is multicollinearity like this one, some papers they actually try to make it like 1.00. They set it. We can set it. This is 1.00, and the rest is actually getting higher a little bit. Okay, because the extra energy goes to another one. Or the best way is actually we can also reduce, eliminate one of this one. So if we eliminate one, this one will be a little bit lower. So up to you which one you want to eliminate, higher this one or lower. That's actually purely up to you. Okay, or like you can check which one among this one is actually the one that is you think is not that a good representation of P, but this is actually very good. The fractal loadings already here. So for me, I'm kind of like, this is not the final model. He only collected. This is the initial. Actually, I forget how many participants. I forget. This is 250. I don't know. This is around 200 something. Can you imagine 200 something? It can be. We can run this very complicated, but I think we can have 304 respondents for this one. We got this one. So if you see this one, no no indicators. It does not mean that it's weird. This is the case of the second order. This is case of second order. This is case of second order, and so on. This is multicollinearity, and if there is another one higher than 1, we call it Hayward. Okay, Hayward cases. That's all. Basically, the thing about the structural equation modeling. If you check the multivariate book, the last one is just the second order, but it's very rare someone to talk until that one. It's my first time actually teaching this one in the class, and it's also challenging for me to run the second order. Sometimes I need to discuss sometimes with the other researchers how to why my model does not work and so on. But yeah, this one works. So basically, if we know the concept of the second order, that should not be a problem. For example, this one, yeah, we know that this is a special case. Okay. Any questions? How was the PhD class?
We can do this.
We can do this. Okay. Maela, what do you think? PhD
All good for now.
for now. We don't know what will happen next. I don't know. Ma'am Bores, enjoy, ma'am, the process.
So I'm already worried. Sir, if ever, can we have a simple study with SEM? If we can try it in the Excel and run it. I mean, if we can have the initial data and run it in the SEM so that probably we can understand the concept for a simple
Okay.
type of SEM.
Okay.
Sorry,
I'll do that. Yeah. Oh, don't worry. I'll do that when we during our individual meeting. So I can teach you for that one. In that one.
Thank you, sir. Somehow that's how I understand some some of the statistical analysis that I tried before.
Okay.
Thank you, sir.
Okay. Anthony, you have questions?
Oh, I forget. Anthony's there. Sorry. Anthony, sorry.
You're fine. I think you're fine.
No questions, sir, but I need to study more.
Yeah. Okay. It's okay.
Okay, so I will upload the PPT in the Blackboard, including the CR, the table for the CR, and then I will upload the some other materials in the Blackboard, and then I will also share the link for the recorded video for today's meeting. Okay, I know it's already late.
Thank
it's
you,
time for yeah. I know it's already late. Everyone is kind of like, I don't know, Gumasi kind of like, oh, I cannot take anymore.
Next week, I know now. Time is 7 p.m. That's 6 o'clock.
Yeah. Sorry. It's 7. Sorry.
It should be 7. Yes. It should be 7. But my class will be like most likely like this one, like 3 hours. Yeah, 3 hours.
Yeah, it's been 3 hours. Oh my God, 3 hours.
Yes, sir.
Yeah.
5 more minutes, exactly 3 hours.
Yes. Okay. If no last questions, then next week I will talk more about the macroergonomics first. Perhaps I go to macroergonomics again, okay? Because we are already very expert, and then I know everyone, for example, Maggumasing will do the thing in macroergo. But Maela, what's your topic? Anthony will go macroergo too. Ma'am Boris will go macroergo too. And then Maela, you wanna experimental?
I prefer cognitive.
Yes. You like experimental, right? So at least I still have someone who will continue the legacy of the experimental because it's not everyone likes it, okay. If
We'll try that too, sir.
yeah, okay, but it takes more time actually, ma'am, for the experimental. But
Okay, sir.
yeah, it takes longer time for experimental, and then for doing one publication with that one, it takes even longer. So let's just play safe first with macroergo.
Okay, sir.
And then after that we can go. If you would like to go with experimental physical ergo, experimental cognitive, we can do it.
Okay, sir.
I know I still remember you like the hand dexterity, then strength, dexterity. Actually, we can do that with a larger sample size. But of course, after post-COVID, now it's impossible.
Yes, sir.
Yeah. Okay. So that's all for today, everyone. Thank you. Good night. See you next
Thank
week.
you, sir. Good night.
Good night.
Thank you.
Bye.
Thank you, sir. Good night.
Bye.
Bye.
Bye. Thank you.